Well, if you didn't pick a handout out when you came in, go ahead and pick one up if you don't mind. There you go. I forgot to remind you guys. So if you've already checked in, we'll go ahead and pick up a handout when you come in. Come on up and pick one up. Hello. Yes, go on. So. All right, week 2. How's everybody doing? Staying warm, hopefully. Supposed to get colder even tomorrow, so just be careful when you're out and about. In the morning, I think it's supposed to be 30 below with wind chill, I think is what I heard, so just be careful. Week 2, go ahead and go to 2 lab in week 2, the 2 lab document that's on the overhead, and go ahead and submit your name in 2 lab so you can get the 50 points for being here. While you're doing that, I'm going to go ahead and go over what's due coming up this Sunday. You got review questions for chapter 1. On the review questions, I just need answers only. So the back of your chapter, do the reading of chapter 1 first if you haven't yet done it. Then do the review questions. Answers only, do it off the grid of Eagle. That way when you're done with them, you can just paste them in here. The way I've allowed them to be posted here is via text box entry. So if you do it like a notepad or on your phone or something, then you can paste them in there. Questions on review questions, what's expected and when it's due. Everything's due, remember, the following Sunday of the current week that we're in. Also, you've got quiz. This one is worth 28 points. Top score out of the 3 attempts. You have 3 opportunities to complete it. And it's not timed. Just make sure you've done the reading. If you've not done the reading, it's going to force you back into a certain section. Or if you forgot a section, it'll force you back into that as well. Just beware of that. And that's a good thing, though. One of the positives of open book. And then research paper topic. We talked a little bit about this or touched base on a little bit at the end last week. You're going to read all about the research paper topic. At the bottom of that document is all the topics. And I think I told you last week, if you don't know one of the terms, to Google it and then figure out from the list of topics which ones you're interested in, and then submit that by Sunday. If none of these interest you, but you can think of a topic that has anything to do with networking, I'm going to let you do it. If you have a question, though, just let me know. And if you have, logic behind why you want to do it, and ask me, here's my thoughts behind it, more than likely I'm going to let you do it. Make sense? So a lot of different topics there. But again, if none of you, I told my 130 class, PCT130 class, I always tell students in this to pick a topic, since it's your choice. Pick one that you know very little bit about, but you're really interested in it. Because if you pick a topic like that, you're gonna get a lot out of it when you research it. And not only that, but when you present it at the end of the semester, we'll get a lot out of it. Does that make sense? So the more kind of passion you put into it, the more you'll get out of it. If you just pick one like, I know this one, I'll do that one, you're not going to get much out of it. And so if you pick a topic that's of interest and you're like, wow, that seems pretty cool. It might be malicious code. It might be, point-to-point technology. It might be token ring. It might be wireless. It might be something not on the list. And you're like, example I think I shared last week, which is a good example that's not on this list, was a student did a presentation on a paper on networking with social media. How does that work? And they dealt with the security aspect of it, or the lack of security, and communication, basically, with networking. So the sky's the limit, really, on your creativity on what you want to do. And I'll also talk about, which I didn't focus a lot on last week, but I will tonight a little bit, since we're talking about you're thinking of your topic. about mid-semester, I think it's right after spring break, I'm going to give you a Thursday to start your research paper outline. Start doing the research on it. Also, not only the research paper, the 5 to 7 pages, but you'll also be presenting 10 minutes a presentation. And here's some different ways to present. You can do the normal PowerPoint, which you've done before or you've seen done before. You can do whiteboard. You can do a demonstration up here. Or you could videotape yourself as a screencast, meaning, videotaping your monitor. It records your monitor and your voice, kind of like I do for podcasting in here. And then you come up and say what your title is, we play it, and then you end with, is there any questions? That's one way. Another way you could do it is you could Skype at home or at work into the classroom and do it that way, or do FaceTime. So all different types of different ways to do it. So you think about that. You got time to think about it. You don't have to tell me now how you're going to present. But I would encourage you, if you've not done a Skype presentation or even a WebEx or a FaceTime presentation, WebEx will probably be better, or Skype, because you can remote your screen to the classroom. Or you've not done a recording of your screen before. Those are all good techniques to learn in IT, because you might not become a teacher in your future, but you'll always be teaching somebody in the field of IT, in whatever field you go into. Does that make sense? So these little tools will help you to present things to people, if that makes sense. Questions on research paper topic? All right, cool. And let's go back to the module for week 2. So we went over the review questions, we went over the quiz and the research paper. You submitted your name in week 2 lab. The podcast that you're watching right now, listening to right now, and participating is being recorded in the 2 podcast. And I wanted to mention, if you've not signed up for the Remind Me app, where I alert you of, like, say, the snow thing we had Tuesday and Wednesday of this week, or Monday, Tuesday this week, campus closures, I need to contact you about, maybe it might be a week I can't come to school, or whatever the case may be. We make other alternatives. That's important to have that Remind Me sign up. The way the Remind Me sign up works, by the way, when you sign up for it, I don't have your real number. You basically just set up an account through Remind Me, and I use that to message you, basically, versus your text messaging, if that makes sense. So it's a good tool, and so it's been used by a lot of schools, and it's secure and safe. And so anyway, sign up for that if you've not yet. I believe everybody in here has, but some of my other classes have not. So all right, let's go and get started. Tonight we're going to be doing a lab on the handout that's in front of you. You'll be working on this side of the room will be group 1, by the way. This side of the room over here is going to be group 2. You already see your sections here. So we're going to go over the discussion in chapter 1. I'll explain the lab, what you're going to do, and what these keys mean. And then you'll powwow in your group, decide how you want it to look, and then you're going to come up and draw it up on the board. And you're going to draw a networking diagram. All right, so let's go and get started on the chapter 1 content. And let's see. I'm going to download this. Should be a little bit better on my screen that way. There we go. All right, so we're going to look at networking computers and client server, peer-to-peer. We will have a Kahoot, by the way, right at the end of the discussion instead of the beginning, because I know everybody's already read the whole chapter 1, right? So no, we'll have a Kahoot at the end of this discussion that'll help you with the Kahoot, even though it's not graded. You'll at least hopefully understand a little bit more than coming in tonight. So we're going to look at some of the difference between client server, peer-to-peer, the different networking terminologies as it pertains to networking. And by the way, the presentations I'm using here at the top of our course, I believe it is, at the very top in the document section is where all the slides are for the PDFs are that I use in class. You don't have to view it while you're in classroom since you're in here, but if you wanted to view them outside of class, you can definitely do that. And then we'll look at some different classifications, certifications that are available. So when we look at computers, why we use networks, there's a reason for it. Years ago, when computers first came about, in the really the late 60s, early 70s, universities, government, that was about it. Consumers didn't have computers then. But they wanted a way to connect to one another. And in the early 60s, DARPANet, which was a governmental agency, connected some computers together on the East and West Coast, some of the universities, to be able to talk to one another and send data. So a network really, if you think about it, hasn't been around that long. We're still fairly in the infancy stages when it comes to everything with computers, really. And now we're growing exponentially much faster each year by year. But we're still fairly in the infancy stage when it comes to technology. Then you have that's network, and standalone computers basically just a computer that stands by itself, not connected to any other computer, like it was when computers first came out. And maybe you might think your computer at home is a standalone. More than likely, your computer at home is connected to Xfinity or some internet connection. Just that alone, that connection, technically, you are not alone. You are connected to some other server. In this case, it would be your ISP, Internet Service Provider connector. There's very few people and very few companies that have computers disconnected totally from the internet and from a network and just staying in there. Now, there's a few places that have it. An example, I know a lot of places in town that have old computers that run a certain machine or run a certain software, and they're totally disconnected from everything else, and they do a great job. They never update the operating system because they did, the software wouldn't work. And so you might know computers yourself at work that do that, or your house. You're like, okay, we're not updating this because if we do, the software is not going to work. So there's still a need for standalone computers for that purpose right there. Also, standalone computers, not only are they not connected, but they use local software and data only. The downside to that would be software you can always reinstall if it crashes, right? The downside of the data, though, is if you don't have it backed up somewhere, at some interim point, you're connected to some entity, whether it be a cloud or a network in your home or work, and you lose that data, You can't restore it. It's very difficult to restore anyway. There are ways you can restore some, but maybe not all. And we'll talk about restoration and stuff like that this semester as well, and backups and all that. And then advantages of networks over standalone, as you can imagine, is if we're which we are in this room, connected to a network, I can have a file on a server and say, okay, everybody click it, download it. And we could, in essence, say like Eagle is a part of our network, right? I have you download a file and view it. Everybody can view it at the same time. I could have a file on the network in here and say, I want everybody to go to this folder on the network and click on it. So sharing is important, right? If I change a file, everybody sees that change because it's one file. Everybody shares. Databases is another important reason for networking. Instead of everybody having their own little database, why not have one database that everybody in the building connects to, right? Can share the customer database, things like that. Saves time and money, because if your client crashes, which can happen, you just get another client with the software and you connect to the data that's on the network. Done. You shouldn't be storing any critical data on a client server architecture, because the whole purpose of client server is all critical data is on the network, right? Your client just runs operating system programs, to access things on the network. That's it. Not to say you would never save anything locally, but you're not going to save anything critical locally, meaning everybody in the building sharing what's on your computer. Does that make sense? Because normally it's not going to be backed up. Normally it's not going to be incrementally backed up or even weekly backed up. And so because of that, you'd want to share things on a server. So that's a benefit of a server. It's also centrally managed. Like right now, I can log into a computer in Rockford at a location that I can start working from here, and it's halfway across town. So I can manage a network from anywhere. I could manage it from California if I wanted to, just logging in. That's the benefit of a network. With a simple phone or tablet or computer, there's tools that you'll learn how to use this semester where you can remote in and manage things remotely and not have to be on that site and not have to be in that building. And they maybe not be in that cubicle where that person needs training on the software or something. You can just remote in their computer. And so what do you need help with? And they have a headset on and you're talking to them just like I'm talking to you now. And they start talking to you and you're helping them through how to use the software. And as they move their mouse around, you're saying, well, yeah, that's right, but you need to do this, like you're sitting right next to them, but you could be halfway across the world remoting in. So central managing also could be, I want to install a new server or create a new server user on a server. So a new employee gets hired, I could manage that remotely, or I could manage from my desk. I don't have to really go anywhere. That's the beauty, again, of networking, is I can manage it from one location. That doesn't mean where I'm physically at, it's where the server is. And so if I have a server in the location, it's connected to all the computers on my network, and I can remote in from that server and connect and install software, install users, printers, whatever it is I want to do, updates, whatever I want to do from that server. Some models, and you'll play with the models tonight with your lab, your in-class lab. Computer positioning, like this room is set in 4 quadrants of 4, but you might see some classrooms in a huge horseshoe, some offices and cubicles all separated. In Japan, a lot of computers are located literally when you walk into a building on a floor, you have these long tables and everybody sits at a table on both sides, no cubicles, just a regular table with chairs on both ends, or on both sides of the table, like a table like this, and that's how they do things. It's all open, it's all open. In America, we mostly have cubicles where people sit in, and then the managers and VPs and such usually push out to the outskirts of a building, like the window interface, and all the workers work on the inside generally as far as placement goes. Control levels over shared resources, meaning in a network, a client server network, I can control, let's say this room over here, you guys are marketing group, this over here, you guys are sales. Marketing can't access certain sales folders. They can't even see them. Sales folks cannot access or see marketing folders. You can do that on a network, client network, that you can't do on a single computer connected by itself. Network models that we'll learn about this semester and play with is peer-to-peer, where 2 people, generally it's 2 or at the most 4 to 5 connected to just each other, and no, not a server, just each other, can share files back and forth to each other, back and forth. Client servers, where basically you have a server in the middle that has all the resources for the entire company. So you have a personal folder on that server that is your folder that you can store stuff on. They call it a personal drive, usually. And it can be anywhere from 5 megs to unlimited space or terabytes of space. All the databases stored on the server. All the critical data stored on the server. Each network, sales and an example I gave earlier, sales and marketing, can have your own folder structure on the server where you store all your stuff in those folders. So different models, and again, when you hear the word model in any form or fashion in any class or in anything you're learning, A model isn't a thing. It's a concept. It's a concept, really, is all it is. Okay, it's not a certain perfect way to do things. It's just a model, basically. On a peer-to-peer, and these are where the connection on a peer-to-peer computer network, where I'm tethered between you and me with, say, a Cat5 cable or a USB cable, or we're connected via Bluetooth, or we're connected via USB or whatever. It's direct authority. Nobody has more authority over each other. We're on the same level playing field on peer-to-peer. When I'm sharing resources, it works great if we're both here. But if we're using a file on my computer every day and I'm gone tomorrow, oh well, can't work on that file. I'm not here. The computer shut down. But you can share resources back and forth to each other. You can also prevent access. So I can give you access to a folder on my computer. You give me access to a folder on your computer. Or I can limit access as well and say you can only have access to this folder and that's it, nothing else. Or you can have access to everything. Traditional model is 2 or more general purpose computers capable of sending and receiving in small offices files, basically. So here's an example of a peer-to-peer. And the backbone of this network, which is showing that black line with the lines in between connected to the computers, could be any type of backbone. It could be a Cat5 backbone like we have in here connected. It could be wireless. It could be Bluetooth, whatever. Most popular is going to be Cat5, like you're connected to these computers here and at home. Wireless. Those are the 2 most popular ways to connect peer-to-peer. And you'll notice they can share files back and forth to each other easily. Advantage, it's simple to set up. Takes seconds to set up. And you and I can set one up now. If you brought your laptop up here, or if I brought my laptop to you and your computer, and I could plug in a Cat5 cord or a USB cord, we'd be sharing files in seconds to one another. Less expensive because there's no other hardware to buy. They're just cords, really. If you don't want to mess with cords, and both of us have laptops, we can connect via wirelessly if you want to, or via Bluetooth. A lot of people don't realize you can connect computers and phones and tablets with just Bluetooth. You're probably familiar with Bluetooth, most of you, with music. When people think of music or Bluetooth, they think of music, right? Stream with your headphones, that's one of the number 1 ways people use it. But it is a networking medium as well. Bluetooth is. You can use it for that as well, or sharing internet. I can share internet over Bluetooth as well. Disadvantage of peer-to-peer: it's not flexible. You can't grow too much. Not secure, really, because fairly easily to intervene and to hack into a peer-to-peer network, because there's not really any security levels or any switches or servers to go through or firewalls to go through or intermediate firewalls. It's all just 2 computers or more trying to get in. And not practical for large installations because, again, just with the file sharing concept, somebody in that peer-to-peer is going to have to be the server for all the files, if that's what you choose to do. Normally, though, in a peer-to-peer, that's not the case. You have multiple people sharing multiple files to multiple people, meaning it's a mess because it's not all one little area, one computer in a business. Usually multiple computers are sharing certain files depending on what this person expertise in. But then again, if they're gone or their computer crashes or that file becomes corrupt, then you're dead in the water with that data, if that makes sense. So not practical for large installations. Peer-to-peer, continuing on, again, there is resource sharing available. It's up to the user, meaning myself or yourself, to share things with each other. Network manager does not have anything to do with that, or an IT person. It's not centrally controlled, meaning there is security issues, crashing issues, corruption issues. And then environments, mainly this thrives well in is a small office with 2 or 3 computers generally. And you might have heard of these last items on here. You got Nella, Freenet, Napster, BitTorrent. You probably heard of BitTorrent, many of you probably. BitTorrent's used for everything from Microsoft, where you want to download a file, uses BitTorrent, to sharing files to one another. You can use a BitTorrent client. And the way BitTorrent works basically is you have, in the Microsoft sense, they have thousands of servers, right? They have one file that people are downloading all the time. We'll say it's an update or whatever. Well, when you go to download the file, it doesn't just download it from that one location. It downloads it from thousands of locations that Microsoft has this file at. And BitTorrent client's smart enough to put all those pieces together and download them separately in 1,000 little pieces from 1,000 locations into one nice package when it downloads it to your computer. So the benefit of BitTorrent is it hits the servers less because you're splitting that file into 1,000 different places, meaning instead of being a 5 gig file that's being downloaded, it might only be like 20 megs per server or something, right? So it's much more efficient to download files using a BitTorrent concept and technology. And what's cool about it is it's faster usually because of that very reason, because you're not using as much bandwidth on each one of those thousands of connections. So you can download the file much, 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 much faster because of that. And then it's also smart enough to repackage all those pieces from a 0 file location to a 1,000 file location, put it all together when it's done downloading. You can even pause a BitTorrent file, come back tomorrow and resume it. And it knows exactly where it stopped and where to pick up. And so BitTorrent is used, popular in peer-to-peer and even non-peer-to-peer, like I just mentioned. Client servers, what we normally play in and work anyway today, where you have the central server. You're going to be doing the lab in a moment in that. It facilitates communication, like when you log in at work, you're not logging into your computer only, you're logging into a network to where you can have access to certain processes, certain procedures, certain files, certain whatever. It authenticates you to log in to that server to have rights to certain things, right? Or to not have rights to certain things. And the great things about just that one thing called logging in and authenticating, with Active Directory on servers, you can actually break apart groups. So I can say, if a person's a part of a marketing group, they get access to all these files, all these programs. Oh, and by the way, they get blocked also for all these other things. So they can't install software. They can't go to these certain websites. They can't go to these certain folders, right? But instead of focusing on what they can't do, all they see is they function in what they need to do. And that's a good thing as well. So when they log in on any computer on the network, doesn't matter where they're at, Active Directory sucks down those rules for that computer, and then they can get their work done. So really, they're not tied to any one computer. They can go anywhere in the building on any device and log in and get access to what they need. If that makes sense. It also has, for the client's side of things, on a client server aspect, it's just known as a personal computer, or it could be a tablet, it could be a phone. These are known as workstations or mobile devices. And also in a client server architecture, everything is centrally shared by the server for not only authentication to get you into the network, but data sharing, like I've talked about, data storage for your personal drives, for your division drives or departmental drives. Devices can also be connected, like your tablets, your laptops, your phones, and no direct sharing of client resources in a client server architecture. You don't want that, because if a client crashes and burns, that data that client had isn't going to be available anymore, right? Or if that person doesn't show up for work, or they get fired, or they quit, or whatever, that data, if it was on that computer only, is no longer going to be there. Some roles here on a computer role for client server. You got the server, right, which has a totally separate operating system that you'll learn about this semester. We'll talk about tonight a little bit. And then you've got clients, which you are used to those. You're in front of a client tonight. You're in front of a computer. It's called a client. It has a Windows 7 operating system. You might have Windows 10 at home, or Windows XP or whatever, or a Mac or Linux. It runs local apps like Chrome web browser, Word, stuff like that, maybe email. You can store data locally, like your email and things. You can share resources on the server. You can even share things like applications that many people don't know about. A lot of companies will buy software that is licensed per use or so many licenses unlimited for the company. Per use means we can do for the sake of this class, and we were a company of 9, 10 people. I could say, okay, I'm going to buy, we don't use it all the time, but maybe 50% of the time people will use it. So I'm going to buy 5 concurrent licenses of this software that runs off a server. And it knows, as a manager for that software, that knows when it reaches that 5 limit. And when a person accesses that program, they run it from the server. It doesn't run from the computer. It runs from the server. Then it keeps track of 1, 2, 3, 4, 5. Then when the 6th person comes in, a little pop-up comes up and says, you have reached your limit of access. You'll need to wait till somebody disconnects to join. Would you like to be notified when somebody does? Yes. And then you'll be notified via email or whatever. But those applications run off a server, which saves time and money for a business, because you're not having to install on every single computer. You're just running off a server and everybody can access it. It might be a shortcut on the desktop. Generally it is. So they just click on a desktop shortcut and they don't know any better, but it's running off a server. All they know is it works, right? A lot of databases do that, by the way, like Access Database was really popular to share on a network. And then 100 people access that same Access Database from all over the building. Devices, talked about that already. And then server is used basically as an intermediary device between you and everybody else in the building and all the other clients. It's a shared resource in the building. And then the communication medium on the table against the walls on everybody's table here, you've got switches, right? These switches are used to communicate between your computer and the server in the Cisco lab, catty corner of the building here. That's where we communicate all of our networking, communications, internet, all that good stuff is communicated through that. So these are switches. Routers are also a smart device, and the one in this room here is over here on this little blue box over here at the top. It's Cisco little blue box router. Yeah, you can pick that up and hold it up. It should be totally loose right now. So you can hold that. That's a router. Yep. That's a little smaller, you'll notice. There's also one over here. This one's live actually on his table over here on this one. This top one actually is a live connection. And so a lot of times routers, well, not a lot of times, routers are always used for rules within the room or in the company for what goes in and what goes out. It's usually the first line of defense for a network. You can set up routers to block certain activity. An example of a real simple example is, say you host your own web server, which a lot of companies do, right? They buy a domain name, but then they want to host it on their site here, like we do on campus. We host a Rock Valley College server here on site, but you type in rockvalleycollege.edu, it goes. We have our ISP through Northern Illinois Century Network down south. They've given us 3 or 4 static IP addresses, external IP addresses, just for whatever we want to use. We use one of those IP addresses, external IP addresses, for the web server. So whenever you type in rockvalleycollege.edu, it has that external IP address that comes through our router. Then it knows, okay, now this external IP address needs to be converted to a local IP address, which is set in the router as a route rule. When it sees this external IP address, it routes it to that web server, and you see rockvalleycollege.edu show up on your computer. And you can even do that at home with a Wi-Fi router. Every Wi-Fi router has what's called a DMZ port, and a DMZ port can be connected to a web server on your computer at home, a simple computer at home, that you could log in if you had the right, external IP address that you paid extra money for, or a certain client running on that computer, you could type in an IP address and it would go right to that computer in your media room or in your bedroom or in the kitchen or wherever. Now, it wouldn't be useful for a large production type of website, but for what you use for school, it probably works fine. And you could access all your files that way easily. If you're interested, by the way, doing that, let me know. I can give you a step-by-step of how to do that, to where if you want to set up your own little file server at home to remote into at any time or to share files. There's a lot of cool tools out there that you don't have to spend any money at. It'll set up all that for you. So if you're interested, let me know. And we'll also learn this semester how you can remote in to your computer at home with some free software from anywhere in the world to access files that you need, or say programs that you need. They might have a program at school that you need, and you can remote in at home from any desktop here in the school or any tablet or even phone, and literally see your desktop as it is at home and fire up an application and start working on it like you were sitting right in front of it. There's a lot of tools that help you with that, with a client-server architecture, with communications, with switches and routers. And here's a little crude example of a client-server architecture. You'll notice the workstations connected to the router or the switch there in the middle. And that switch is also connected to a printer, and it's also connected to a server. Server requirements is different than the one you're in front of, the clients you're in front of. It needs its own special operating system, and it's called a network operating system. Windows has a network operating system for servers. Macintosh used to, well, they do have a special one now still that they keep. Linux can serve as either a client or a server operating system. But some of the server examples are these type. Microsoft already mentioned, Unix, Linux, Mac, and OS X, which is Mac as well. But a network operating system, or called a NOS, it manages the client data and resources, can connect multiple users to that operating system, which a normal client cannot, can control user access to everything on the network, restricting network access, dictating computer communication rules, and supplying applications to client. Now let's talk about the computer rule. The real simple one is everybody in the building can only log in to the network from 6 o'clock in the morning till 6 o'clock at night. You can set that rule up. Meaning if somebody tries to log in before or after, not going to be able to. You've locked it out through the network. That's just one configuration out of thousands that you can set up. You can also set it up to where nobody can access Microsoft updates from anywhere in the building as long as they're connected to the network. It'll block it. You could also say every time somebody logs in, they're going to run this login script that's going to map all the drives on our network to your desktop. And even if you delete it today, tomorrow when you log in, or tonight when you log out and log back in, it's going to put that desktop shortcut back on your desktop, whether you do it on purpose or on accident. And the list goes on and on of things you can block. You can block from a rule in a server to not even see the control panel when a person logs in. They can't even see it. To install printers, to do anything. So a lot of really cool restrictions you can put on computers, depending on what that person or that entity, that group needs to do. The server also feature relative to clients has much more memory. It's not uncommon for a server to have, like most of your computers at home might have like 8 gigs, 12 gigs, 16 gigs of memory, right? It's not uncommon for a server to have, up to a terabyte of memory, up to half a terabyte of memory on it. But you have to remember, these servers could have, your computer at home might have 4 processors in it, or a quad processor, what they call it, quad core processor. Servers can have up to 32, 64 processors just for one server, all connected together, so much more powerful, as you can imagine. But you have to remember too, they're connecting everybody in the company to that operating system. It also is equipped with special hardware, like built-in, many more fans to cool things off, They can have much bigger hard drives that can be connected to them, and you'll learn about all the different types of hard drive configurations. There's RAID 4, there's RAID 5, there's RAID 6, there's RAID 7, and all these. What these are is basically where drives are daisy chained together to say you have 10 drives connected together and you have, say, 10 terabytes of data. They're mirrored. It's set up in a RAID format to where they're mirrored, meaning if a drive fails, your computer can still run. You just hot swap it out, the bad one, and put a new one in. It constantly keeps a copy of all of your files on other drives, basically, constantly. More expensive, as you can imagine, but with servers, you're not really worried about expense as much as being up all the time and working. So that's why you're going to pay more. An average medium-sized server, operating system, and everything, just that part alone, probably going to cost about between $5,000 and $8,000 roughly for a medium-sized server, roughly, for a company, around that, which is normal. But again, it's running 24/7, connected to 100 plus computers, constantly being used all the time. Disadvantage of peer-to-peer, as you can imagine, a lot more complex, just a little bit I've shared so far, and you'll learn more this semester. And its maintenance is much greater maintenance on a server than a client. Because you're not just dealing with the server only, you're dealing with all the connected users and how they connect and what do they bring into the piece. And you have to concern about viruses and malware and all these things that are connected that could be infected on the server because of all these connections. So you have to have antivirus checks and a much more stringent rule setup for connectivity. Advantages of relative peer-to-peer, I already mentioned this, credentialing from one place, and any place on the network you can log in through that server. So any computer, I can log off of this computer, walk to your computer, log in, log off to that computer, and it doesn't matter where I log in, I'm logging in through that server in that one location from any location in the building or in the network. Multiple shared resources can be accessed anywhere on a server. Central problem monitoring, diagnostic, correcting capabilities. User response time is much quicker because when a client starts acting up, I'm immediately alerted of who the client is, what's going on, and can fix it much quicker because I'm alerted. Now you have to set up those alerts, but they can alert you via text message. They can alert you via email, a whole bunch of different ways. Efficient processing on larger networks because of more memory and processing power. Things can get done quicker, right? Just because you have more to deal with. Now I'm going to stop there for a second. A server is never used like a client is used. Like tonight, what you guys did when you came in, what was the first thing you did when you got to your computer? Somebody tell me. First thing you did. You logged in, and then what'd you do? Signed in, and where'd you go after that? To Eagle, okay? So let's talk about Eagle, internet. On a server, you never access the internet. It's never done. And why do you think that is? Why do you think you never access a server or a website or a web browser? You never open one up on a server. Why do you think that's important? Why do you think we don't use internet on a browser on a server, just for general browsing and looking for stuff? Just take a guess. Why do you think you wouldn't want to do that? Not that you can't do that because there's a browser on servers. Why do you think you would want to do that, you think? Yeah. Yeah, you're at risk, right? Anytime you go on a web browser, regardless of what you're doing, you're always at risk anytime you open up a web browser. So if you never open it up, you don't have to worry about it. You never open up a web browser. That makes sense? So it's not uncommon to walk into a server, open up the operating system, log into it, double click on Internet Explorer, and you get that first screen that says, this is your first time opening it up. Because it's never used on a web server or on a client, a file server or a network server at all. In fact, programs like we use tonight, like say Eagle, firing up Chrome, but maybe Word or Excel, or what's some other programs you guys use on your computer at home or at work? every day. What is it? There you go. Yeah, good. Gaming, right? Gaming platforms. What else? Anything else? Calculator, maybe? I don't know. What is that? Office program. Maybe some, maybe like Adobe Photoshop, maybe some graphic stuff, maybe some media stuff, maybe watching movies or something. I don't know. Those type of programs, anything I just mentioned, you'd never use on a server. All a server does is utilized for, as far as setting up. Once you set up the operating system, network operating system, then you configure. You definitely use components within the server to configure the server, but then that's it. That's all you do. And then the only time you're maintaining the server is changing those configurations, patching updates from Microsoft or from antivirus, which is constantly updated. And that's it. Because the way it works with antivirus, the antivirus software downloads to the server, right? And then there's a package within the server that disseminates that antivirus to everybody in the company at certain times that you dictate. It can be every hour. It could be twice a day. Whatever you say, that's what it's going to do. You could also push updates to the clients, again, when you want to do it. After you've tested them to make sure they work, then you can push it. It's very scalable as well. I can add new computers at any time. A new employee comes in, no problem. 10 new employees come in, no problem. Just add 10 new users, give them the computer with the software they need, connect them to a network connection, done. They're good to go. And most IT departments have what's called an imaging system, to where if you're a new employee and I get a new computer for you as my new employee, for the company's new employee, I take this image that we have stored on the network somewhere or on an external drive or something. I push it onto a new laptop, or say it's a Surface Pro or whatever. Take that image, put it on there, log in as you, the new employee, set up email, and that's about it usually. And whatever software that's used in that company, close the laptop, go to the network, and the network already sees the client, already recognizes you try to log in the first time. You're already on the user. Have already created the user on the network for them to log in. And so once you've done it a number of times, it doesn't take long to do what I just mentioned. You can have a turnaround. If you have a computer, an image, and know what the username is and where they're going to be working, you can have that all set up in hours, have it done, and it's good to go. So it's very easy to scale and to add. Popular for medium to large scale organizations, as you can imagine. Now we're getting into some definitions of networking that's important as far as what types of networks you can set up. The first is LANs, which stands for local area network. You've heard of that one, many of you. It's relatively for a small space like this room, this building. It started in the 80s and became popular, more popular, peer-to-peer based was taking place. Today, everybody is set up. All companies usually have a LAN within their company. A MAN is taking the next step, is where you take a building and connect another building. So we have here on this campus, WTC, PEC, CL1, CL2, JCSM. That's considered a MAN, because we're literally in between each building is an underground tunnel that's big enough for a golf cart to drive through, that has a fiber cable that connects each building to each other building. And then in the basement of each building, there's a drop box that fiber comes into. And from that fiber box, it then goes into a first switch that then connects, much like the switches you have on your table, that then connects to each floor by floor. And then each room usually has a box with a switch in it. And you've probably seen them in some other classrooms, usually like a little gray box that has a switch in it that connects all the computers. But the source of that building is in the basement, in a box that has fiber that runs underneath a tunnel in between each building. And they originally built back in the 50s, those tunnels were, and they still are used today. And there's maintenance people that literally live down there that you never see. I'm just kidding. You do see them, but it's a joke basically. But no, Maintenance done now is replacing fiber every once in a while, painting the ceilings. There's some other lines that run down there besides fiber. You got electric lines, you got water lines, you got gas lines, as you can imagine, running down there. But a MAN is basically extending the boundary of a building to other buildings. Like this is a perfect example here on campus. Then you've got the WAN connection. A WAN connection is where basically you connect location to other locations. So here we have the Mulford Center. Then you got the Stenstrom Center, which some of you have been there, or by Jefferson High School. You got the Bell School Center, where the retirement facility, retirement teaching is. Then we have other satellite campuses here, the RBC downtown location, the second floor of the R Star building. That's another building. So those regional buildings or those regional sections are separated and connected by a WAN connection. Anytime you hear the word WAN connection, it's a internet connection, basically. Whatever internet that building has. Like R Star has their internet connection through Rock River Internet. Our Stenstrom Center, they're connected through Illinois Century, which we are here on this building. But irregardless who they're connected to, it doesn't really matter who their ISP is or service provider for internet, because when we connect to them, there's a router in each building, our Star location, the Stenstrom Center, Bell School, our building. There's a router in each building that first line of defense coming in from the other building. So literally when they log into Stenstrom and those computers, they're logging into the servers here in the building here. Same with Bell School, we're logging into servers here. Same with our Star servers here, all through routers over the internet, whatever backbone of internet they're using. Now, you can set up direct lines of backbone, meaning we can spend money and literally run a direct line, right? Like AT&T run a direct fiber line from this building to Stenstrom. Much more expensive. Don't need it. It's kind of a waste of money to do that. But there are companies that do that. Like an example, Coca-Cola here in town that has like a distributor. I think it's on Forest Hills, I think. Anyway, they have a direct line that drop. It looks just like an old warehouse, really, where they stock the trucks of pop every day and go deliver. There's a direct line. They call it a T1 line from that building to Madison, a direct line. But again, that's Coca-Cola. He's got a little bit more money. We do have a direct line here from Illinois Century from this location, and I believe it is the Bell School location. But again, it's not that. It's a distance, but not that long of a distance when you compare to how long it is from here to the Stenstrom Center. Is quite a bit longer distance. So what we're using for the Stenstrom Center and the Bell School and the R Star is basically just over the internet, over the backbone of the internet, wherever our service provider is. So you'll notice on each one of these locations, there's a router here on the left. There's a router here on the right, in the middle here for that location. And so these are two locations. Technically, the way this one shows, this whole thing I'm showing here on the right will be considered a MAN location, maybe like here. And maybe over here would be like, say, I don't know, Stenstrom or something. And then this WAN link is that internet connection link in between the buildings, in between the geographical locations. So WAN connects two or more geographical locations, could be in the same state, or it could actually be across continental divide. It could be in another country. Like an example, Microsoft, Coca-Cola, they have distribution centers worldwide, right? So they're going to be using a lot of WAN connections. Another WAN connection I forgot to mention is satellite. A lot of them use satellite now. Anybody heard of Elon Musk, right? He's got this new thing now. He always has a new thing, but his newest thing now is broadband through satellite, low orbiting satellite. And what that means is he's going to put like tens of thousands of low orbiting satellites all over the world that'll basically become broadband connection, broadband. Now, one of the reasons for that somebody was talking about the other day, which probably makes sense, is his Tesla models all have internet built in to them when you buy a Tesla. So you probably know what provider they're probably going to be using once this is done. So it's going to save them some money as a company for sure. But the whole premise besides that is to offer broadband connection to third world countries who otherwise wouldn't have internet connection. And he has the money to do that. So anyway, long story short, the reason I mention that is you can have a WAN connection via satellite as well. You could have a WAN connection via satellite. So a comparison to WAN and LAN is really just geographical comparison. That's all it is. Same technology, but different medium and the longevity of it, long distance of it. So it uses slightly different transmission medium, like here in the room, we use Cat5. We do have fiber, by the way, that does run somewhat in the building in limited locations from, say, rooms to the server room. But mainly we're using Cat5 to connect everything, which is cheaper. And then in between building to building, definitely it's fiber. But here in a WAN environment, it could be satellite, it could be your ISP, it could be a direct line, whatever. It could be even point-to-point satellite. And in a LAN, there's also difference in a greater variety of technologies you can imagine, like the one I just mentioned between us and all of the other locations we have for RVC. Because of the different ISPs, we're using different technologies as well because of that. And then network connection can separate offices in the same organization, separate offices in different organizations, and gone are the days where you had to have it all in the same building you were located at. Many companies, when they log in, are logging in, physically logging in, authenticating and sharing resources across state lines when they log in every day. And they don't even know it. Most employees don't know it. They just know they get the data and they get the access to things. But, larger companies like JCPenney, has stores all over the U.S., McDonald's, stores all over the world. When they log in and the corporate gets numbers on an hourly basis of sales, that's all done through a WAN connection all over the world, constantly, and many different types of connections, as you can probably imagine. So here's an example of a simple WAN. Again, in the middle is the WAN link, which is the internet. Anytime you see a lightning bolt, that's usually an internet connection. And then on both sides is the router that takes that internet connection on both sides and then disseminates to the, so on the right side, let's say a client logs in, and we'll say the left side is where people in the entire organization log into a server, maybe over here. I'm circling with my mouse. So everybody in the organization logs into this server when they authenticate every day. But when this client logs in the morning, he or she does not know that the server's over here. They just know they logged in successfully and have access to all their files. That's all they know. Over here, this client logs in, it's logging in here. But again, doesn't matter. They could be, left side could be in the US, the right side could be in Germany, for all we know. And it's going to work all through that WAN connection. Common elements in client server. A client basically requests resources from a network computer. The client also has a human user usually in front of it. Maybe, well, we all know, you've heard of it, humanoids are here. Might be a humanoid on the other end possibly. Client software is installed on the workstation. On the server side, you've got the network operating system. You've got the network shared resources being shared, folders, applications. And then the workstation may or may not be connected to the network. And again, that's kind of at the end. It's still around. Like I talked about earlier, the personal computer is standalone. They're still around in older facilities where they need them, and the software works. They're usually still there. Now we're getting into stuff we're getting into in this semester as well, like a NIC card. You might have heard of that. That's what causes your computer, phone, tablet to work on a network, is a network interface card. There's wireless ones, there's wired ones, there's cellular phone ones, tablet phone or tablet device ones as well. They're inside the computer or tablet or phone, connecting that computer to the network. And they're generally connected via some medium, whether it be a wired medium or a wireless medium. those two types. On the wired medium, you've got Cat5, that's against the wall back there. You've got fiber on the wired side. On the wireless, you got wireless. And so two types of NICs, wired NIC, wireless NIC. And you can set up a house on, many of you probably do already, your whole house is set up via wireless. You don't have any wires running from your wireless router to other computers. Now, you might have a wireless router from Comcast or Xfinity, and it's direct. You might have your game console plugged into a port just for speed purposes. It's going to be much faster than wireless, but probably all your other connected devices in the house are going to be wireless. They're going to be, you know, maybe your TV is wired directly. Your smart TV might be wired directly. Again, going to be faster connection than wireless. So anything streaming, probably a good idea to have wired. NOS, again, network operating system that we talked about. Microsoft, Mac, Linux, all has them. And it is a different operating system because it does manage users, groups, security applications, and other network functions. That's a picture of what a NIC card looks like. And this part I'm circling now on the overhead right here, this is actually, and you can't see it, and you know, numbers aren't there, but it's a MAC ID or MAC address is what they call it. It's a unique address, much like a VIN, or exactly like a VIN on your vehicle, a VIN number. It's comprised of a unique code for that manufacturer. Popular makers of NICs would be like 3Com is a popular one, Intel, but the most popular probably D-Link makes some as well. 3Com is a pretty popular one though. But every NIC will have that. And one of the labs we do in the 130 class is all spoofed to Mac, where you can make each computer look like it's the same MAC address through software. But you'll notice on this one here, it's seated in the motherboard right here, seated inside the motherboard, which you will do a lab where you'll take out a NIC and put a NIC in, just like this. The Cat5 is plugged into it, and voila, you're connected to the network. Also, some other terms when it comes to network server, client server, you've got the term called host. This is a computer that enables network resources shared by other computers. You could also say host and synonymous for server. You hear that as well. A node will be anything like your client you're sitting in front of, to your tablet, to your phone, to a laptop. And it uniquely communicates over what's called a network address. Not an IP address, which you'll learn about and probably heard about, but a network address that's literally assigned by the network for that ID or for that node. And then connectivity device, allowing multiple computers of multiple parts to connect and exchange data. Connectivity device would be your switches at the end of the row. Routers is also a connectivity device between that network and other networks. Segment is a group of nodes connecting one to another for traffic, using the same communication traffic. Like an example of a segment might be you have a data segment that just data on your network flows. You have a voice segment that the voice on your network flows for, like voice over IP for phones, as an example. Backbone, that determines what the network falls on, what it runs on. Does it run on Cat5 totally? Or maybe it's a conglomerate of Cat5 fiber. Maybe it's Cat5 fiber wireless. A lot of times I have all three. Topology, you'll be playing with some tonight on your handout. We'll go over topologies in a little bit, but it's 4 topologies: bus, star, ring, and hybrid topologies. It's basically the layout of a computer network. So here's an example of a backbone you'll see here. And a backbone, as you can see, can be multiple different mediums. We could say on the right side, between the server, client, and the switch is Cat5. Maybe between the switch and the routers on both sides is fiber, we'll say. And you get a multiple mixed backbone, but you're going to have a backbone, and you just need to know what that backbone is. And what determines a backbone type, by the way, is a number of things. One is cost. One is location. So if a backbone is going to be in a manufacturing hub where there's going to be a lot of noise and static electricity, more than likely you'd want fiber because it's less noise susceptible and will not cause problems when big machinery runs and big engines run. Whereas Cat5 would cause problems because it's not as shielded as you'll find out as fiber is. Fiber is perfect for office because you don't have a lot of stuff going on in here. Not a lot of machinery running and engines running, so it's not going to interfere with the data. Okay, so on your sheet on the first page, it kind of looks like this a little bit. You can read the one on the overhead much better. Top left is the first type of topology, which is a bus topology. How many has Xfinity or cable internet or cable TV at home or both? You have one of both. Okay, so you plug in the back of your TV then, or your cable modem, a coaxial cable that screws in right to that modem or to the TV. That top left bus network uses or used that coaxial cable. It's just as fast and efficient, and sometimes maybe a lot more speeds than our current Cat5 and Cat6 connection. But as you can imagine, much more expensive to create. It's got a lot more to the cable than the Cat5. Usually, sometimes originally had a copper center, and then after that, some maybe some steel or aluminum sheath after that, and then another grid after that, and then finally maybe a sheath of plastic, and then finally another plastic after that. So a lot more expenses to that. So, but bus was the first, and the NIC cards actually, you'll see one in a second, but there's a NIC card specifically designed for Cat5 or for a coaxial plug-in. We call it BNC connector, you'll see. The bottom left was the second type of in the history of networks topology. It was a ring topology. The way it works on a ring topology is when you're sending data on a ring topology, this computer here is sending data this computer here. What's going to happen is if a 5 meg file, it'll duplicate it on the two computers left and right. So it'll be 5 meg, 5 meg, 5 meg of that same file. Then it moves over here, drops this one, 5 meg, 5 meg, 5 meg. Moves over here, drops this one, 5 meg, 5 meg, 5 meg. It finally recognizes the file made it here. Then it's going to drop it from that computer there. So it's duplicating it. Redundancy is a term on purpose in a ring topology. And a lot of ring topology networks actually will a lot of times have two NIC cards, one for input and one for output. And governmental still uses a lot of ring, banking, New York Stock Exchange. And one of the reasons for it is the data might not be as fast on those networks, but it's going to surety data is going to get there for sure, if that makes sense. A lot of redundancy, but you need to make sure data is there, right, in banking, in New York Stock Exchange, in government, and military. You need to make sure data gets there. It's not the fastest, but it's more efficient as far as making sure the data gets there for sure. The top right is the newest and greatest topology, which this became popular when Cat5s were created and started being manufactured. And you'll notice in here, they brought in the switch. Now, switches were available or started to be available back when buses and ring was started, or right after they got started. But star basically is just your computers connected to a switch or a hub, like you'll learn this semester. And that switch then or hub is then connected to a file server for people to connect and to log in and share resources like we've been talking about. And if I want to add another computer, I just simply plug in another Cat5 connected to a computer. It's been added. The bottom right is a conglomerate of everything called a hybrid, which a lot of companies have if they've been in existence for 20 plus years, because they've literally been in existence since the bus has been around and the ring has been around. So they might still have some older networks in those places like Stenstrom, like trying to think of what else. Blank. I'm brain dead today. Extension ones have been around. I guess give me some other local companies that have been around forever here. Can't think off the top of my head for some reason. Well, you know what I'm talking about. A lot of old companies, a lot of older networking companies. I can't think off the top of my head. Anyway, I'll think of them. I'll blurt it out here eventually. But a lot of companies have been around 40 plus years, 20 plus years, 30 plus years, have all these types of networks in their buildings. So could walk into these types, and they don't replace them because they still work, right? They still work and they still function. So why replace them? Other elements common to network client is you've got protocols that need to be installed or set up, data packets going back and forth between different nodes, specific addressing, whether it be IP addressing as you do on the server side, to network addressing, which is done on the network side, to transmission medium. What transmission medium you're going to use? You're going to use Cat5, you're going to use fiber, you're going to do both. So here's an example of the cabling. You'll notice talk a little bit about the coaxial cable. Much more involved as far as costing. 1, 2, 3, 4 levels, 4 tiered levels to create it. Second one down, twisted pair. That's the one we do in here. And then we have unshielded twisted pair as well, which don't have as much shield as that middle one. And then the last is fiber, can be made of either glass or plastic in the middle. Glass or plastic, much longer distances, and light travels through that node. You can go thousands of miles in some cases, depending on the wire that's used. Transatlantic ocean, underground fiber. Fiber is generally installed underground today. And then radio waves. Before the nursing building was built, I don't know if you guys remember where that building is now, there used to be a satellite farm that would be a point-to-point technology farm that basically would point to other companies here in town for we could teach a seminar or whatever and point it to that. And so we moved that side. We still have those. We moved them down Mulford. If you keep driving down Mulford, you'll see them. There's a whole bunch of satellites where it's in that area there. Network service is another one. Functions provided by a network needs to be available. Most visible that everybody's familiar with is email as the most visible type of network service. And then vital services like printing that you'll do in your lab tonight, file sharing, internet access, website delivery, remote access, voice over telephony, voice over IP, video services, and network management. File services, anytime you want to share files, you have to turn that on. If you don't turn that on, they won't be able to share files. Print services. And then accessing services like you have to turn this on the server side and client side both to be remoted into or not. And then also on the LAN, as far as making sure people have access to their network resources, network devices, to see if they do. A lot of times there'll be diagnostic problems that will rise up and can notify those in IT to fix them, these access services. And then communication services, things like this all has to do with basically emailing today. Everything else, faxing is still around a little bit, but not as much. Spam, you might have heard of. I don't know if I mentioned this last week, but 97% of emails coming to companies are spam. Okay, it's blocked. It's just blocked totally. Internet services, we need that. Management services, we need that on how to manage your network. And Active Directory is one of the number one ways that's done in a network operating system. And to trafficking and load balancing. Okay. Now what we're going to do is switch gears. I'm going to fire up Kahoot. So get your phones out and I'll get this connected. Snoop Dogg's in. Well, waiting on a couple more. One more. All right. There we go. I think there's 10 questions. Group of computers and devices. Network, standalone computers, peer-to-peer. Answer as fast as you can. Network is the correct answer. Good. Snoop Dogg is in the lead, followed by Sleepy, The Chosen One, Yankee Deuce, and Conrad Kurz. Not connected to other computers. Standalone computers, network. Awesome, standalone. Easy one, right? Same. Well, I think sub to PewDiePie came in on that one. Snoop Dogg's still in the lead there. Advantages of networks over standalone computers. Easier to set up, central management. Advantage of networks over standalone computers. Central management on networks. Not really easy to stand up or set up, a little harder to set up, usually. All right, so we got Snoop Dogg, Yankee Deuce, Conrad Kurz, Pepperoni's coming in, and then sub to Pi D Pi Pi. Oh, I'm mispronouncing that. Network models. Peer-to-peer, cable tethered, client server, neuron links. And there could be more than one answer on this one. There could be more than one answer. Client server or peer-to-peer, either one is correct. Snoop Dogg, Conrad, Yankee, Pepperoni, and sub to PewDiePie. Equal authority. Peer-to-peer, client server. Good. Same list as before. Good. Central resource sharing. Client server, peer-to-peer. Client server is correct. Network operating system. Clients or servers. Correct. Servers is a correct answer on that. All right. There's a lead. Oh, 4 players just hit an answer streak. 7. Network confined to a relatively small space. LAN, WAN, or MAN. Yes, it is a LAN. Good job. Network extends beyond building boundaries. LAN, MAN, or WAN. MAN is the correct answer on that. Connects 2 or more geographical networks. WAN, MAN, or LAN. WAN is a correct. Remember, geographical meaning location, like Stenstrom, or our location, downtown. All right, awesome. Conrad Kurz, Pepperoni, and sub to Pi Pi P P P Pop. Yeah, whatever that is. Good job. Awesome. All right, now what I need you to do is get in, kind of meet those that are on the outskirts, come into the middle of the room. So what I mean by that, you 3 are good there. So I'll just need I'll need you to come up to here, and then I'll need you two to come here in the middle. Take these chairs, and then I'm gonna go over the rules here, not the rules really, but the guidelines of the lab. So I'm gonna take a little long. What you're gonna do basically is get the piece of paper out that's in front of you. And I'll pull it up here on the overhead. All right, so let me pull up the document and go over it with you on the overhead. Okay, first page we already went over. Second page is the NIC card. Third page. Let's go to the fourth page. Now everybody's gonna keep these, by the way, since you already gave me your name. So disregard the name, class name, date. You don't need to do that. But let's read together the example of what you're gonna do. It's gonna draw a star topology, and it's up to you to decide. One of the first things when you build a network is do what we're getting ready to do. You just kind of brainstorm where you want things to be in your building, right? Now, the first thing you have to decide as a group is what type of company are you going to have? It can be it can be an insurance company. It could be a farming company where everything's going to be in farm buildings. It could be an insurance company where you're located on one floor. It could be whatever you want it to be. It's up to you to decide. It could be, over the years, I've had students choose what I just mentioned to the Bahamas, and it's located 3 offices located in 3, kind of buildings on the end of a pier, like these little, built out of bamboo type of stuff or something, whatever. It's up to you. There's no limits to what type of layout you want for your buildings. So you'll decide that first as a group. Then inside of those buildings, you need at least 3 buildings, basically. You're going to have 12 clients, which stands for C for computers. You'll have 2 printers, P with a circle, 2 file servers, which is the FS in a box there. And you could also throw in there some switches as well. 1 or more switches can be in there. You don't need to draw lines, though, in between the switches and computers for this diagram. You just kind of put them in there where you want them, but you don't need to draw the little Cat5 wires and stuff. You'll indicate that there are 3 buildings. You don't have to put the 175 feet apart thing. Just you'll draw the buildings up here. And so I'm going to draw a real crude example and then let you go at it. So I'm going to draw a very simple example. It's going to be on 1 floor. It's going to be three rooms basically on 1 floor. And again, this is a very boring example. You guys can be much more creative than I am here. And so these here represent these 12 computers. And the way I want it is I want a printer for people to kind of share here. And I'm even going to build, I'll let you guys build if you want other buildings the size of 3. I'm going to have these other buildings here for 2 file servers. I'm going to put in here. And I'm going to put a switch in the corner of each room. Okay, corner of each room. And yeah, so it'll connect my printer, it'll connect to my computers, it'll connect to the printers, and it'll go over to the servers. So there's my layout. Okay, and we'll say my company again, it's an insurance. Mine's an insurance company in 3 rooms of a building. And there you go. That's my example. But again, yours could be however you want to do it. Make sense? Everybody got it? So decide first of all, kind of greet each other a little bit, and then decide what company you're going to have. Somebody in your group will draw it out, and then somebody else in your group, once you're done, will come up and draw. In group 1, you'll draw here. Group 2, you'll draw here. Make sense? There's enough markers for everybody. So go forth and start talking. All right? There you go.